Hello guys, this is Astha Sharma from MTech IT 2K21 batch. Uh, this is a paper of data science internal 2. Let's start our discussion. Question number 1. Write algorithm for decision tree induction. We have to first discuss what is decision tree induction. Decision tree is a supervised learning method used in data mining for classification and regression methods. It is a tree that helps us in decision making purposes. The decision tree creates classification or regression model as a tree structure. Decision tree algorithm. Step 1. Begin the tree with the root node, say S, which contains the complete dataset. Set 2. Find the best attribute in the dataset using attribute selection measure, which is ASM. Step 3. Divide the S into subsets that contain possible values for the best attributes. Step 4. Generate the decision tree nodes which contain the best attribute. Step 5. Recursively make new decision tree using the subsets of the data set create in step 3. Continue this process until a stage is reached where you can't further classify the nodes and call the first node as a leaf node. Decision tree use multiple algorithms to decide to split a node into two or more subnodes. The algorithm selection is also based on the type of target variable. Let us look at some algorithm used in decision tree. Uh, IDE3 extension of D3. Build decision tree using a top-down grading search approach. C4.5 Success of ID3. CART Classification and Regression Tree. CHAID Chi-square Automatic Interaction Detection performs multi-level splits when computing classification tree. MARS Multivarieties Adaptive Regression Split. Let's start question number 2. Question number 2 is, what is attribute selection measure? Explain 3 of them. Answer. Attribute selection measure, also known as feature selection criteria or split criteria, are used in decision tree algorithms to determine the best attribute to split the data at each node. Method 1. Random selection. Not a good method. It can lead to inaccuracy and may give wrong results. That's why it is not preferred to use this method. Method 2. Using information gain. Information gain is based on the concept of entropy from information theory. Entropy measures the uncertainty or disorder in the set of examples. Information gain is the reduction in entropy or the gain in information by selecting a particular attribute for splitting. Node with lowest entropy and more information gain is selected as a splitting attribute. Method 3. Using Gini index. The Gini index is a measure of impurity. It represents the probability of incorrectly classifying an instance in a dataset. A lower Gini index indicates a purer dataset. A lower Gini impurity indicates a purer node, and that node is selected as splitting attribute. This is the question number 2. Here, then we discuss question number 3. Define and write mathematical expression of information gain, Gini index, and reduction in impurity. Now the answer is, first, information gain. First, we have to discuss its definition. Information gain is a measure used to decide the order in which attributes are tested in a decision tree. It quantifies how well a particular attribute separates the data into classes. Mathematical expression we see on the screen. Then we discuss second, Gini index. Definition of Gini index is, Gini index is another metric used for evaluating split in a decision tree. It measures the impurity or disorder of a set of data points. A lower Gini index indicates a more pure node. Mathematical expression of Gini index we can see on screen, where C is the number of classes and the probability of classes I is the proportion of data points in the nodes that belongs to class I. Third, reduction in impurity. Definition. In the context of decision trees, the reduction in impurity measures how much the impurity decreases after a particular split. It is used to assess the effectiveness of a split. Common impurities measure includes Guinea impurity. A lower Guinea impurity indicates a pure node. Entropy. Lower entropy signifies a more organized or pure node. Classification error like Guinea impurity, a lower classification error indicate a purer node. The reduction in impurity is used as a criteria for selecting the best split at each node during the tree building process. Mathematical expression we can see on screen, that is where I parent is the Guinea impurity of the parent node. K is the number of child node after the split. Di is the data set for the ith child node. Mode of Di is the number of instance of the ith child node. Mode of D is the total number of instance in the parent node. II is the Guinea impurity of the ith child node. Let's discuss question number 4. Explain concept of overfitting and repunching. Prosing. Answer. Overfitting is a common problem that needs to be handled while training a decision tree model. Overfitting occurs when a model fits too closely to the training data and becomes less accurate when encountering new data or predicting future outcomes. In an overfit condition, a model memorizes the noise of the training data and fails to capture essential pattern. Key characteristic of overfitting includes first, high training accuracy, low test accuracy. The model may achieve very high accuracy on the training data but perform poorly on new unseen data. Second, complex models. Overfitting often occurs when the model is too complex, capturing noise in the training data. Third, memorization. The model may memorize the training data instead of learning the general pattern. Tree pruning. Tree pruning is a technique used in decision tree algorithm, include those for classification and regression. Decision trees have a tendency to grow ex- excessively deep, capturing noise in the training data and leading to overfitting. Pruning is the process of removing parts of the tree that do not provide significant predictive power, thus simplifying the model and improving its ability to generalize. We have two decision tree, an unpruned decision tree, a pruned decision tree. There are two mainly type of tree pruning. First, pre-pruning, which is also called early stopping. This involves stopping the tree building process before it becomes too complex. For example, you may limit the maximum depth of a tree, the minimum number of samples requires to split a node, or the minimum number of samples in a leaf. Second, post pruning. Pruning after construction. This involves growing the full tree and then removing or collapsing nodes that do not contribute signifying to the model's predictive power. This is often done using techniques like cost complexity pruning, where a cost function is used to assess the impact of removing a particular subtree. Tree pruning helps prevent overfitting in decision tree models, ensuring that the tree captures the essential pattern in the data without memorizing noise. We have discussed this paper, which is of internal 2. Thank you so much.